2-3 is about what's called normal distribution, which we're going to talk a lot about that in the next few weeks, if something is considered normal. Here's the basics. It's got to be symmetric data. Normal stuff is fairly symmetric to almost exactly symmetric, which truthfully doesn't happen that often, right? It's like we have had a lot of skewed data in the past. So it makes what's called a bell shape. I even put a picture of a bell on here. Do you kind of see what I'm talking about with the bell shape? Like this data right here, fairly symmetric. This data right here, fairly symmetric. That's what we're going to call is normal data. So then we're going to see some weird, nasty little symbols right here. Please don't be scared of them. There's a symbol for the mean. It looks like this. It's hard for me to even draw that. It's the Greek letter mu. I could care less if you pronounce that, but I think you've heard of the Greek letter pi before, like you know from geometry class. So that's the Greek letter mu. We'll call it mean. He's the mean, okay? And then the standard deviation, sometimes they do S, sometimes they do the S sub x, sometimes they just do SD, so that's our standard deviation in that situation. So let's dive in, man. We're just very barely touching the surface today, and then we'll dive in deeper later. The scores on our recent quiz were normally distributed. So they did some math behind it. We'll do that math next time to see if something is actually normal or not, right? But normally distributed with a mean of 82 and a standard deviation of 2. Here's our job today is to put that on the bell curve. Here's a fact, Jack. The mean always goes right there. So are you cool that the mean is 82? Because they told me so. So we'll put an 82 right there. And then every one of these tick marks is how many standard deviations you are away from the mean. So if I was to do this, this is one standard deviation away, and we believe he's to the right of that guy, so it's going to get higher on the number scale. If the standard deviation is 2, shouldn't that have to go up by 2, right? So that would be 84. Does that kind of make sense where 84 came from? So like if the test average was an 82 and you scored an 84, does that make sense that you are one standard deviation above average, right? You know, one above average. Then right here, this would be 86 and this would be 88. You see how it just keeps going up by 2 every time. So 1 standard deviation above the mean, 2 standard deviations above the mean, and 3 standard deviations above the mean. Then it goes backwards on the other way. We got to go down by 2. So if this is 82, how do you feel that that would have to be 80? Then 78, and then 76. Does it make sense where I'm getting these numbers from? The average on the test was an 82, and the standard deviation was 2. Very round numbers to deal with. If we go back to this, how long did it take for us to hit the stopwatch? Our average was 5.02 seconds, and it had a standard deviation of 0.25. So like we'd have to fill that scale out with all those weird little numbers, which is not an easy thing to do. So that's why we're going to use some applets to do the next ones. Can you see that they have, we need to read these stories because they keep coming up all semester long. So they take like this vocab test. In this state, they're calling it the ITBS. Here we call ours FastBridge. Do you know what I mean? Like what they're taking some standardized test right here in Gary, Indiana. And this class of 7th graders, they had an average of 6.84. Are you cool with that? So like whatever the scoring scale is, the average was 6.84 and a standard deviation of 1.55. They say, fill that out on this guy right here. Well, bro, I don't want to add all these weird numbers together. Are you cool that the mean always goes here, and don't I have to add 1.55 to it every time? Like my calculator will totally do that for me, but the applet will do all of it for me. If we please go to the applets, so let me get back to our page. We just go to the main page right here, and we're getting to use a new one today. We are under the probability section. Do you see where it says normal distributions right here? So we're going to use this one a lot. Click the normal guy. And then don't worry about all this crazy nonsense up top. We need to put 2 bits of information in here. The mean, you see that box right there? We're going to put the mean in. The mean was 6.84. And the standard deviation, they automatically put a 1 in there. We need to delete that out and put the 1.55. Those are just the numbers from the problem that we were on about these kids' 7th grade ITBS scores or whatever. Are you cool with where I put these guys? This is the mean, and this is the standard deviation. Hit plot distribution, and does it make the normal curve for you with all of those nice little numbers on there for you as well? So they put the mean right in the middle, right? That's the average score of everybody, and then it went up by 1.55 every time or down by 1.55. So I'll let you copy those onto your worksheets. Go to your worksheet and put all those numbers down on there. I'll pause the video here and let you do that. Really kind of basic. It's still cool if you're not quite sure what this is all meaning. The idea today is, can we get the numbers in the right place, and we'll start doing a little bit with them on the backside, and we'll get better and better and better at it. So like on the next one, they got a baseball player's batting average. It's just like how often they get a hit compared to when they get up to bat. They say for a normal Major League Baseball player who's at least came to the plate 100 times, the average batting average is .261. So that goes there, and they say there's a standard deviation of that little number. Let's make the normal curve, but let's let the applet do all the work for us. So you can go back here and just change your numbers. The mean was .261, and the standard deviation is .034. Should always just like double check that you typed them in right. Hit plot distribution, and then you can totally copy those guys down. And just to dive into it, I know not a lot of people know a lot about baseball. Sorry, I do, you know. But this dude right here is your average Major League Baseball player. They're hitting .261, which basically means they go, whenever they go up to the plate, they average a hit every like 26% of the time. You know, .26 moved over. This person right here is better than average, right, by 1 standard deviation. This person right here is 2 standard deviations, and this person is considered elite. Like, look at that. There are very few, like, look how low that curve is. If this was a dot plot, very few dots in that situation. Elite, if you are 3 standard deviations above the average, like, you are killing it, bro. This person over here, major sucky. It's like, you are bad, man. You are 3 standard deviations below the mean. You probably need to get on a different club or get out of Major League Baseball kind of stuff. So that's kind of weird. So if we go to the backside, this will be the most valuable worksheet you'll have because of all these crazy percentages. Don't lose this worksheet. Here's what the empirical rule states. That's a weird word, but empirical only works for a normal curve. So this has to be normal. Here's what happens. Cool that the average is right there in the middle on that tick mark. If you're within 1 standard deviation of the mean, is that cool that you could be to the right of it or to the left of it? Does that kind of mean you can be 1 above or 1 below? So here's the facts. If it's truly normal, then 68% of the data will fall in there. 34% of the data will be above the mean, and 34% will be below. Can you see on my cool little bracket that I have above it that there's where the 68 came from? 68% came within 1 standard deviation of the mean, which is pretty stinking close to our data right here. If we go, I deleted our data, sorry, but our data was almost normal looking. You know, it was very close to the bell curve. Most of us were within 1 standard deviation of that average in that situation. So then it also shows that if you want to be within 2 standard deviations of the mean, it's going to happen for a fact that 95% of the data would be in there. Here's all of these guys added up together to be 95%. And if data is truly normal, it is so stinking close that 100% of the data will be within 3 standard deviations of the mean. You see it's 99.7. There is some very rare cases that some people are extremely elite. You know, if you're using like baseball for the example again, there could be some people like Shohei Ohtani who is just way better than everybody else for some reason. He would be more than 3 standard deviations above the mean. So do me a favor, and could you also put these little dashes right underneath here? You're going to thank me next week. Like underneath every one of those tick marks, just kind of put a little dash out, and we're going to like kind of show how much data there is in certain sections of this guy, and then it'll make answering your homework questions so much easier. So right here, we're going to put 0. 0% of your data is at this. There is no data at this tick mark. And again, this only works if you are normal. At the first tick mark, there is 0.15% of your data going to be between there and there. Not even 1%. Like, very rare will you be more than 3 standard deviations below the mean. Then, if you're right here, just trust me on these numbers, you will have 2.5%. That is this and this added together. There's 2.5% of the people who will be below 2 standard deviations of the mean. Then if you're under 1, that's 16% of your data is all to the left of that. But I'll bet you the next number makes really good sense to you, right? It's like all of that is pretty strange at first. Trust me, we'll get used to it. The next number is 50%. How do you feel about that, guy? That half your data, if it is normal, will be less than the mean in that situation, right? So 50% on the left. And then check out where this next one's going to come from. Do you see we're already at 50%? I need to add another 34%. Yes, I will. I need to get all. So the next number will be 84% because I added an additional 34%. Then I'm going to take this 84 and add another 13.5% and say, like, dude, 97.5% of the data is right there. And then 99.85 and this. But it was asked if I could zoom in because I know this is really small, so I'm going to zoom this in and then we'll talk about it. Good. So there it is, just a little bit better. We'll jot all those guys down and then we'll use them as the chapter goes along. It's a lot of weirdness right away. It takes a lot to understand. We're still getting better at what a standard deviation even is, right? You know, so just hang with me. Done this for 4 years in a row. It will get better. Right? We'll get these numbers down, and then we'll start making some sense of this stuff, and it all ties together. So here we go. Let's answer some basic questions down below. It says the heights of U.S. adult men can be modeled by a normal distribution, so that's important, that it is normal, right? Sorry, guys. My poor computer. Okay, let's pick the pen. This has got to be normal for us to do this trick. So this guy is normal. Do you see how they give you a mean and a standard deviation? Put that into the applets. Put that into the applets. Put that into the applets. Once you get it in the applet, go put the numbers on the normal curve bar like that. Cool. So now that we have like all those numbers written down from the applet, check out how easy these questions will actually become thanks to this little picture that I have up here. It says 68% of the data values are between blank and blank. We're going to use this dude right here. How do you feel that 68% of the data, when normal, is between the first standard deviation, high or low? So how do you feel that that would be between these two numbers right here? Isn't it going to be between 65.7 and 70.3? Aren't those the guys on the tick marks? That is 1 standard deviation below the mean and 1 standard deviation above the mean. So we just got to get used to this empirical data. Sometimes people call it the 68, 95, 99.7 rule, you know, because that's what these percents are. And I know that is strange to y'all. I would just kind of ask you to trust the numbers on it. Like 68% of the data is usually within 1 standard deviation of the mean if you have normal data. So where did I get these guys from? Here and here. 1 standard deviation below, 1 standard deviation above. Where would 95% be? How many standard deviations? Could you tell me? How many standard deviations? 1, 2, or 3? 2. Do you see there's 1 tick mark, 2 tick marks? So the 2 standard deviation numbers are that 63.4 and 72.6. Are those the right numbers, just out of curiosity, based off some of your facial? Is that what the applet gave you? Okay, just make sure I had the right numbers. Okay. So, and then 99.7% of the data, that's always going to be within 3 standard deviations of the mean, baby. Like almost 100% of your data will be within that, right? If the data is normal. Going back to our stopwatch thing, like I would say almost all of us, our stopwatch times were within like 3 standard deviations of 5.02, which would be 5.79, you know, it's like, or like 0.75 below that. Like they were almost all in there. A couple of outliers here and there. So that would be between the 61.1 and the 74.9. You can never truly say that 100% of the data is within 3 standard deviations because there's just some oddballs every once in a while. Like somebody's going to throw some data off. But most of the time, 99.7% of the data would be between 3 standard deviations if it's normal. If you are skewed, that's not going to happen, right? You have to be fairly symmetric. So the last part of the questions, it says blank % of the men are between 68 and 70.3. So here's 68. And here's 70.3. Are you with me on that? Use the chart. Isn't that between these two guys right here? How do you feel about 34% of the data will be in between there, right? So 34. Blank % of the men are between 61.1 and 63.4. So that would be between these two dudes right here. So I go to my chart. That's between 3 standard deviations below and 2 standard deviations below. How do you feel about 2.35% on that guy? And then the last one, how many % of men are taller than 74.9? That's this guy right here. So it's tough to even see on my chart, but it's not 15%, it's 0.15%, like barely any of them. There are totally human beings taller than this, right? You know, that is 6'2", almost 6'3", right? That's how tall that person is. There's a bunch of people in the world that are taller than that. But percentage-wise, it's only less than 1% of the men in the world, according to this data, would be less than that, right? Or taller than that. So, cool. Let's just try the homework and see how we do. And use this chart, baby. Like, let me help you with it. Cool. So let's give it a shot.